This video is going to go over how to graph piecewise functions and then answer some attributes about them. So before we get started, just know that you might have to know some attributes of these. And those attributes are usually like domain, range, in behavior, and then continuity. So if you don't know how to do those already, maybe go watch a video on this stuff before we get too far ahead here. Okay, essentially what's going to happen with these piecewise functions, a piecewise function is basically just saying there's multiple sections of line, and the breaks where these multiple sections of lines kind of switch off are going to be right here. They'll specify. So like this one, there's going to be a break at -1, and then there's going to be a break at +1. So back onto this question. At 2, something's going to happen here. And so like you'll have one section of line. I know this is not correct, but you'll have like one section of line here, and then you'll have like another section of line there. And basically all you have to do is graph each section and get your endpoints correct. You'll have to either have an open circle or a closed circle, and I'll show you how to find that, but it's just from these right here. And once you graph it, then you answer attributes about it. So let me just show you some examples. This first question, my break is going to happen at +2, an x value of 2. That's here. So when I do these, I'll usually like maybe draw a line there or a dotted line or something like this, just to know that that's where it switches. Now the first part of this line has a value of 3. That's like it's saying y equals 3. Y equals 3 is a horizontal line right here at a y value of 3. So it looks something like that. And in terms of your endpoint right here, you get that from whether or not they have a or equal to symbol there. So this one has an or equal to symbol, meaning it's going to be a closed circle at that endpoint. Okay, now I move on to my other section of line. Everything greater than that 2, so everything to the right side of it, it has a y value of -1. That's like it's saying y equals -1. That's a horizontal line starting at -1 like here. So it looks like that. And then you just got to get your endpoint correct. So this one does not have an or equal to. So it's going to be an open circle where that break happens. Now, if you were answering attributes about this, the domain of this, how far left, how far right it goes, is all real numbers. The range of this, how low it goes, how high it goes, the range is only y values of -1 and y values of 3. So you would just write like a squiggly line, -1, 3. The end behavior, if I go to -infinity, my f of x, my y value, so if I go left, I'm leveled out there at +3. And if I go right, so x approaching +infinity, my y value levels out there at -1. And then the continuity, this right here is a jump. So you would say jump at, and then give the x value where that happens. Well, it happens at the break of 2. And by the way, I was watching this video back. When you say jump at 2, really you're supposed to say jump at, you need to give the x value, x equals 2. Okay, so just something to think about. All right, let's go ahead and get started on the second one here. They give you 2 equations basically. This is like it's saying y equals 1. And basically for everything not equal to 1, you're going to use this equation. And exactly at 1, you'll use this equation. So this right here is just going to be a dot. Let's go ahead and graph this x squared plus 2 first. This is a quadratic with a vertical shift up 2. So it just looks like this. Now, the only thing that is going to be different here is that at this spot of 1, the next value of 1, you're going to have a y value of 1. So that means at exactly 1 here, you're going to have a y value of 1. It's just going to be a dot there. What that does to this blue line is it essentially means you're going to have a hole there. So it's going to look like this. You're going to go up to here. You're going to have a hole right there. Then this line's going to continue. That's what this piecewise function would look like. So in terms of the attributes of this, let me see if I can move this over a little bit. Okay. In terms of the attributes of this, the domain would be all real numbers. Because this quadratic does not have a domain of all reals because of the hole, but this red hole is covered there. So every single x value is covered. So the domain is all reals. The range, however, would look like this. You have a point at 1. So you would put a little bracket of 1, and then union with, and then this graph, the blue one, is from 2 to infinity. So bracket 2 to positive infinity, like that. The end behavior, you can put a plus minus infinity here because both these arrows are going the same direction. So your f of x, as you go either left or right, it's going up to positive infinity. And then the continuity, this right here is not a jump. It's a removable. So I would put removable at x value equal to 1, like that. Okay, these bottom three, we'll start with this one on the left. It's going to have 3 sections of line. So the first break is going to happen at -1. The second break is going to happen at +1. So the first thing I'm going to do is I'm going to graph this section of line. Everything that's less than or equal to -1 is going to be this x plus 2 equation. So if I graphed it without restricting its domain, it would look something like this. But they say you have to cut it at -1. So I'm going to restrict its domain to just be at -1 and everything to the left. And it's going to be a closed circle there because this is an or equal to sign. So you go and you put a closed circle there at an x value of -1. The next section of line is going to be the cubic here, x cubed. That's from everything from -1 to +1. It's going to be a cubic. The cubic function looks like this. And basically, you're just going to cut it at -1 and at 1. And it's going to be open circles on both ends. So it would look like this. Something like that orange section. Then the last section here, everything greater than 1 is going to have this equation. So what I do is I just graph that line as if it wasn't restricted or anything. It would look something like this. And then I go and I restrict it. So everything greater than or equal to 1 on my x values would put it here. And at 1, it's going to be a closed circle because it's an or equal to sign, like this. So I know it looks weird, but this is what this equation would look like. Okay, in terms of the attributes of this function, the domain, everything is covered because it goes left forever, right forever, and all the holes in the middle are covered. So the domain is all real numbers. And you can even get the domain from like looking over here to see if -1 gets covered and if 1 gets covered, which they do, and to see if it goes on forever both ways. The range, however, this one's kind of weird because the green line alone does the range for the entire function because it has the lowest that you go and it has the highest that you go. So when I answer range, I'm really only going to look at the green line there. It goes down forever to -infinity, and the highest that goes is +2. The end behavior, both of these arrows are going down, so you can use a plus minus here. F of x, since it's going down, in behavior is negative infinity. And then these right here, this and this, these are jumps in terms of continuity. These are jumps. So I would say jump at x equals -1 and at x equals +1. All right, this next one here is also going to have 3 sections of line, and the breaks are also going to happen at -1 and at +1. So the first thing I would do is I would graph this line. X minus 3 would look like this. Then I would go and I would restrict its domain. So that's only for everything less than -1. So everything to the left of that vertical line that I just drew. So erase all this to the right. You don't need all that. And at -1, it's going to be a closed circle there. Like that. That's the first section of line. The middle section is going to have open circles on both ends. And it's just a -x². So it's just a quadratic that points down. And again, it has, like, if it wasn't restricted to its domain, it would have kept going and been a quadratic that you're used to seeing. But since they restrict its domain from -1 to 1, that's all you get out of that equation. And it's open circles again because these symbols here don't have or equal to. Okay, and then the last section of line would be this -x plus 4. I like to just graph linear as if nothing's happened yet. So graph it without restricting first, and then go and restrict it. So this is for everything greater than an x value of 1, so I don't need this left section of line. And then it has an or equal to, so that means it's going to have a closed circle here. So in terms of the domain you can get from here or from looking here. All those open circles are covered by, like, this green point, so the domain is all real numbers. The range, this is another one where this green section of line can cover the whole range for you because it has the lowest that you go and the highest that you go. So my range here would be from -infinity to a y value of 4. Nope, that's at 3. To a y value of 3, like that. The end behavior, both these arrows are going down forever, so you can use a plus minus. And it's just going to be f of x equals -infinity since they're going down. And then again, these are jumps. So continuity, I would say jump at x equals -1 and at x equals 1, like that. Okay, this last section of line is going to have 2 sections to it, and the break's going to be right here at 0, an x value of 0. So the first thing I would do is I would graph this 2 greatest integer of x function first. For this one, I would definitely start at the origin because that's how I've been trained to graph it. Like this. Now, this is the parent greatest integer function, but if you look at this, they have a 2 there. So these steps where it's going up 1 over 1, that's incorrect. You have to actually go by 2's here. So it would actually look like this. And this is for everything less than 0. So that means this whole thing right there doesn't even exist. Because it has to be an open circle there, and so your open circle there is right there. So this is what this part of the graph would look like. Weird, I know. Just trust it. And then you have a negative root function. This negative root function just means it's going to, look, this is the parent square root function, something like that. So a negative root is just going to swing down like this. It's got a closed circle at 0. So just put your closed circle and then just draw the square root function. It looks something like this. So this is what this would look like. And in terms of the domain of this, the domain of this is all real numbers. Everything, even over here, it gets covered. Every single hole gets covered by the one above it. So the domain of this is all real numbers. The range of this, however, This part's weird, but it doesn't matter because this square root function has the lowest that you go and the highest that you go. So you don't even need to worry about the greatest integer function in terms of the range. Your range is going to be from negative infinity because that green arrow going down, and then that green dot, the highest it goes is y value of 0, like that. The in behavior, you don't have in behavior this way because there's no arrow really, so I wouldn't, me personally, I wouldn't think about in behavior going that way, but you do have in behavior going right, so I would write limit as x goes to positive infinity. F of x is going down to negative infinity. And then as continuity goes, you have a bunch of jumps over here. It's an infinite amount of jumps, so I'm just going to put jump. And yeah, that's basically how to graph piecewise functions and then name the attributes about them. So hope this video helped.
Okay, I went back and watched my video, and I couldn't stop thinking about this. The in behavior of a greatest integer. I'm not necessarily saying there is no in behavior. I'm just saying me as a teacher, I wouldn't ask about that. But if your teacher is asking you about that, if you go left here on your x's, you're going down. So the in behavior, if you go the other way, you go down as well. So that means you can use a plus minus here because either direction you're going down. And then one last thing, in terms of the jump, you can probably get away with doing something like this. You're saying ... means all those values before it, and then you not putting a ... on the 0 is telling me that it's stopping at 0. So if you were asked to specify about where that jump was, this is probably how I would write it. And in terms of the in behavior, you technically are going down forever if you go to the left. So just wanted to make that update.